Pre-college, quadratic formula. What are the roots of the equation ax squared plus bx plus c equals 0? This question is really just asking you, do you know what the quadratic formula is? And if we examine each of these, hopefully we can kind of take a look at what may be right or what may be wrong about each of them. The first one is negative b plus or minus the square root of b squared minus 4ac all over 4a. There's your mistake. It is not over 4a, it is over 2a. The second one, b plus or minus, right away you can clearly see the mistake is it's supposed to be negative b plus or minus the square root. Negative b plus or minus the square root of b squared plus or minus, nope, it's just supposed to be minus. And so hopefully this is the answer. Negative b plus or minus the square root b squared minus 4ac all over 2a. That is the quadratic formula. It's one of the larger formulas that you do need to have memorized for the Algebra 2 Trig Regents exam. It's on the exam pretty much every year, but it can be very useful, and it's really just something that you have to memorize. It, you know, in the next generation math students that are taking the Common Core math now actually get this on a reference sheet, but those of you taking the Algebra 2 Trigonometry Regents before then do not. So it is something that needs to be memorized. You know, you could write it on top of your page for now, but you know, at the same time, you really should take some time practice, you know, memorizing it. You could even Google a YouTube a video on a quadratic formula song, and you'll probably find some strange stuff. But whatever you got to do to memorize this formula, get it done. So the roots of the equation are what? Now, at first glance, you might think, all right, I could try to factor this, and you could try to factor it. It would require AC factoring, but there's a chance it wouldn't work, and that would mean that the roots are irrational. Like, I don't know what the answer is off the bat, but if it is C or D, then factoring is not going to work. If it's A or B, then factoring would work. So you could try factoring, but you don't have to. You could just do the quadratic formula, and that's what we're practicing today, so that's what I'm going to do. So let me rewrite this formula one more time. So x equals, and don't forget about the x equals. A lot of people just jump right into the negative b. Well, it's x equals because you're solving for x. You're finding the solutions. You're finding roots. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, that means this is your a, this is your b, this is your c. The numbers, the constants and the coefficients. Not a is not a, not 2x squared. A is just 2, and b is not 7x. It's just 7. So let's do some substitution. This is going to be x equals negative b would be negative 7 plus or minus. Now, negative b doesn't mean that this number is always negative. It just means opposite of whatever this number is. So if b was a negative 7 here, then we'd have a positive 7. It's just negation means change the sign. So plus or minus, and by the way, this plus or minus right here, this is what's going to get us 2 answers in the end. Plus or minus the square root of b squared. Now, I tend to jump right to 49 when I do my substitutions here. B is 7, and 7 squares to 49. If you want to substitute it first as 7 squared, you can, but I like to jump right to just whatever it is squared. And this number will always be positive. Even if b is negative, it's positive because anything squared is positive. Even like negative 7 squared is also positive 49. So that's always going to be positive. Then we have a negative 4 times a, in this case 2, times c, in this case negative 3. And that whole thing is over 2a, which I tend to jump right to that 2. In this case, it's going to be 4. 2a is just doubling your a number 4. So the things that I do right away is I square b and I double a when I do my substitution. But if you want to do a straight up substitution first and then do those things, you can. The next thing I'm going to do is I'm going to simplify this piece and that piece only. So let's see, we have x equals negative 7 plus or minus the square root of 49, and then I have 3 numbers, negative 4, 2, negative 3. And just use your calculator for it if you don't want to do it in your head. Negative 4 times 2 times negative 3. And that's going to give us positive 24. And that positive 24 is crucial because that means it's now 49 plus 24. See this minus sign up here, it's actually a negative sign attached to that 4. That's a negative 4. And notice that I have 2 out of these 3 numbers are negative. When 2 out of the 3 numbers are negative, they multiply to positive, and the whole thing ends up being a plus in here. If only the 4 is negative, or if all 3 are negative, then it will stay a subtraction of 2 numbers. And over 4. So that's the only thing I do in that scenario. And then next, I simplify the number in here. And so I'm just going to do equals negative 7 plus or minus the square root of 40, 60, 73 over 4. And this number is crucial because this is called our discriminant. And we'll have a day dedicated to just talking about discriminants and sum and products and all the different things we do with quadratics. But that's a discriminant, and that is an irrational number. It cannot be reduced, and in fact, we're done right now. The answer is C. But at this stage, I would look at this and see if I could simplify it. Sometimes it comes out to be something with an I, sometimes it's a square, sometimes it's an irrational but can be reduced, and so on and so on. Let's look at one more example. Y squared minus 3y equals 9. The first thing is we need to make sure it's set equal to 0 first. And they're using y squareds here instead of x squareds. No big deal. It would actually mean the parabola is on its side, but as far as this goes, it doesn't really affect it. So y squared minus 3y minus 9 equals 0. And so let me do my first round of substitution here. And I guess it would be y equals instead of x equals in this case, because these are y squared instead of x squared. Again, not that big of a deal because it's more of the procedure this is testing us in. So negative b would be positive 3 because b is negative 3, so opposite sign would be positive 3, plus or minus the square root of b squared. Even though it's negative, it squares to positive, so negative 3 squared is positive 9, and then a negative 4 times a, which is 1. When there's no number there, we know it's a 1, times c is negative 9. And that is all over 2a, and 2 times 1 is 2. So 3 plus or minus the square root of 9, negative 4, 1, negative 9 is positive 36. You can use your calculator if you need to. It's definitely going to be positive, a plus, because, again, I see I have a negative 4 and a negative 9, and 2 negatives multiply to be that positive, that plus right there. All over 2. It's going to give me 3 plus or minus rad 45 over 2. And so my discriminant is 45. And so what can I do with 45? First of all, it's not square, which means that my roots are irrational, but it can be reduced. It is positive, so they are real, so that's going to get rid of these i's. That would be if it were negative 45. So it is real, but it can be reduced with using the numbers 9 times 5, with 9 being the square, and so it's going to reduce to be 3 rad 5. So let me rewrite this to be 3 plus or minus 3 rad 5 over 2. And then I want to see if I can simplify. Now, it's pretty obvious I can't simplify here, but say this was, a 6 over here, then I could divide all of them by 3, something like that. But you can't in this case, and so this is my final answer, and that does correspond to choice D. All right, now it's been about 9 minutes, so I'm going to stop the video here, but just remember we're going to practice a bunch of these tomorrow and the different ways it could go. If this is negative, it could mean an imaginary. I look to see if I can reduce. Now it's got to be all 3 of these. Maybe we could draw a heart around these 3 numbers. It's got to be all 3 of them if I am going to reduce. It can't be just 2 of them. But that's it, and we'll get a good amount of practice of this tomorrow in class. See you then.